All right, welcome to the robotics class for March the 2nd. As I said right before I turned on the recording, I am going to record it because there are a few people missing and or who are going to have to leave early. And I want to make sure that you don't miss anything. So leave your cameras turned off and let's record. Okay, I have looked at the assignments that you guys turned in, the one that was due today. I've looked at all of them. Some of you you like to wait till the very last minute, but I was able to look at them. And those of you that did them did it really well. A couple of you still haven't done it. And you know, it's funny, it's the same people every time that aren't turning in homework. Guys, you really got to do this. Now, of the people who did turn it in, I could see that everybody had done it well, but a couple of you had a little trouble with the buzzer. Let's talk about the buzzer. And in some cases, I know what the problem was. So here is my circuit. Hang on, let me get a little drink of water. My throat's getting funny. All right, hopefully that'll help. All right, so let's watch my circuit and see how it goes. So I'm going to start the simulation. And all right, so now they're the motors. You can see the motors are running now, just like they're supposed to. At close, yeah, basically 100 RPM. Now, the motors are a little unstable. You'll notice this one goes slightly above 100 a little bit, and then it drops down. And sometimes they go a little bit below 100, but on average, they're averaging about 100. All right, now, the part that some of you had trouble with was the buzzer. When I push this button, the buzzer is supposed to sound, and also the motors are supposed to stop and back up. So I'm going to push the buzzer, and the buzz might be really loud. So I apologize if this is really loud. All right, so watch what happens when I push the button. And did you notice that the motors stopped there, and now they're running backwards? And now one of them is going to run forwards and the other one runs backwards. Okay, there you go. So that means the robot is now turning. And so now they stop for a second and now they're going back full forward again. Okay, so this is exactly what it's supposed to do. Now, some of you, the motors worked like they were supposed to, but your buzzer didn't. Well, the problem was because you didn't put in a delay, and I don't think I warned you that you needed to. So I didn't take off any points if you did this. I considered it my fault. When you play the buzzer, when you play the speaker, if you don't put in a wait, then the speaker sometimes doesn't play right. Okay, so like right here. Okay, so you can see that this is where I tell it to turn on the speaker, and I tell it that I want this tone and I want it to play for 1 second. If I don't have this wait statement in here, then it's not going to work right. So tell you what I'm going to do. I'm just going to make the wait be 0 rather than pulling it completely out. So basically, it's like I don't have that wait in there. All right, so let's see what happens now if I do it so without the wait statement. So you guys have all seen that it works fine with the wait statement in there. All right, now let's see what happens if I'd have that wait time out. So here I'm going to push the button. And of course, now it's working, right? Geez. Just my luck. Okay, so that wasn't it. All right, so that means that there was something else going on there. All right. So yeah, I should have tried that one before I did the class. I was certain that that was the problem. I was so certain that I figured, oh, I don't need to test that. I know that's the problem. Well, I see I was wrong. Isn't this great? I love teaching. I learn new stuff all the time too. All right, so bottom line, if you had trouble with the buzzer, but everything else worked fine, don't worry, I gave you credit. All right, so now we are ready now to finish up our real robot. So you guys remember that what you should have done by now is you should have got a box and you should have put the motors inside the box and the wheels on the outside. And I recommend that you put a spoon on the bottom here. So now we have a robot that can drive around. What I want you to do today is to finish the robot. So if you look inside the box, you'll see that I have now included all of the guts that I didn't have before. So previously, all we had was the motors, but now you can see I've got an Arduino in there, and here's the breadboard with the H bridge, and here's my battery. That now this is the battery pack that actually has 3 AA batteries in it. This is the one that I like to call the big battery. It's the one that's going to power the motors, because the Arduino cannot put out enough current to run these motors. We have to have a separate battery for that. And notice that what I've also got in here is I've got this 9-volt battery with the clip on it. And so the 9-volt battery is here to power the Arduino. Now, what I did last night was I took the Arduino and I connected it up to my computer, and I put the program into the computer, or I'm sorry, put the program into the Arduino. And now the Arduino will remember the program. I can disconnect all power to the Arduino, but the Arduino still remembers the program. So as soon as I put this 9-volt battery in here, then the Arduino will start running. Okay, so now the 9-volt battery goes in the black pin. It doesn't go in the silver one where the computer goes in. It goes in the black one over here. So here I'm going to plug it in. Okay, and I'm going to turn on my battery pack. Okay, now watch the wheels. You see how the wheels are both turning? All right. So this robot is now going to run forward. And now if you keep watching the wheels, you'll see that in a second they're going to stop eventually. Okay, there. Okay, and now it's running backwards. Okay, this one's running backwards, this one's running forwards, and now it's going to start going forward again. Okay. All right. So what I did is I have programmed my robot so that it goes through a sequence that's a little different than what I had to do last night, but not terribly. Basically, it's this. And by the way, this is going to be your homework for tonight. So let me share my screen. So this is what I want you guys to do tonight, is I want you to put the Arduino inside your robot and get it running, so that let's assume that this is a top-down view here. So let's assume that you're in a helicopter up above looking down, and this is the robot, and you've got a wheel right here, and you got a wheel right here. And what you're going to do is you're going to put a mark on the floor somehow. You're either going to put a piece of tape on the floor, or maybe you're going to set a coin on the floor or something. So here you're going to put the robot so it's exactly on top of that dot. And then I want you to program the Arduino so that the robot, when it starts up, the robot will move forward a distance of at least 3 feet. If you want to do more than 3 feet, you have my blessing, but it must be at least 3 feet. And then once it's moved up 3 feet, it needs to turn around and come back to the starting point. So it needs to end at the same place that it started. Now, I will leave it up to you as to how you want to turn around. The simplest way to do it would be simply to have your robot, okay, so have the robot so that it goes forward, and then have one of the wheels turn forward and the other wheel turns backwards. So the robot will just spin in place, and then the robot goes backward. That would be the easiest way to do it. That's the way that I would recommend you do it. But if you want to get fancy, you certainly can. So what you could do is say, all right, here's your starting point. And then let's say we're going to have the robot come up here, and then maybe it's going to turn and go like this. Okay. And then maybe it's going to come here, and then maybe it's going to turn and come back this way. I don't care what path you follow. As long as you move a distance that is at, from here to here has to be at least 3 feet, okay? And then you need to end up at the same place that you started. So if what you prefer to do is just go forward, and then once you get forward, you're going to spin around, and then you're going to go straight backward, that would be the simplest. And that's what I would recommend that you start with. But I didn't spell simplest very well, did I? Let's try that again. Simple. I just cannot spell. Okay, simplest. I think I got it this time. Okay, so that would be the simplest. But if you'd rather do something fancy like this, okay, that's fine. As long as you end up at the same place that you started, that's all I care about. And as long as you moved at least 3 feet away from the starting point, okay, those are the only things that I care about. Okay. Now, let me warn you that you're going to find out that robots don't behave exactly the way that we want them to if we control them the way that we're controlling them. So tell you what, let's go in and let's look at the homework assignment that I gave you tonight. If you look on Canvas, you'll see it's written right here. So this, completing your real robot and driving it using what's called open loop motor control. So that's the key. What is this open loop motor control of which I speak? Well, let's click on it and find out. I wrote up a little thing here so that it will hopefully help you to understand it. All right. So let me just repeat what I said before. So this is what I want you to do for your homework tonight. I want you to mark a spot on the floor somehow, tape or coin or something, I don't care what. I want you to set your robot on that spot, and you're going to have pre-programmed the robot so that it will move at least 3 feet away and then come back to the starting point. And then I want it to stop when it gets to that starting point. And by the way, there's a little trick here that we need to talk about, because you guys hopefully know that Arduinos, they don't like to stop. An Arduino likes to just keep on doing the same thing over and over and over and over again. If you want to tell the Arduino to do something once and only once and then stop, it's actually a little bit tricky to do, but it's not a difficult trick. We'll talk about that in a minute, but I don't want to talk about that right now. Okay, so after the robot has returned to the starting point, I want you to measure the distance from where the starting point is to the place where the robot finally stops. Now, hopefully that distance will be 0, but it won't be, okay? So I want you to read this. In fact, tell you what, let's have one of you read this. So how about if, let's have Trey read it. Trey, can you please read the part that I have highlighted in blue here?
Don't be surprised when you find that the robot's motion isn't exactly what you program it to be. Like for instance, if it doesn't go straight, even though you program both motors to run at the exact same speed. Also, don't be frustrated if the ending point is slightly different every time you repeat the test, or maybe even a lot different.
Okay. And the reason is because what we are doing right now is called open loop motor control. So what does that mean? It means that we're telling the motors to run for a certain amount of time, and we're just hoping that the motors will do what we tell them to do. Well, I got bad news, guys. Motors don't always do exactly what you tell them to do, okay? So like we're hoping that both of the motors will run at exactly the same speed. That doesn't happen. These motors are not all exactly the same. And so even though you're running both motors exactly, you think you're running both motors the same, you're pulse width modulating them exactly the same, they both got the same voltage, you think they're both going to run at the same speed. I got bad news for you. That doesn't happen. You think that robot is going to go straight, but it's actually not. Right? So why doesn't it? Well, because one motor is slightly different than the motor. And also, if you run the test one time and then you come back later and you run the test a second time, you're going to find that the robot is going to behave slightly different each time. And the reason for that is because when the battery voltage drops a little bit, even if it just drops a little bit, okay, then the motor speed is going to change, which means that the robot isn't going to quite follow the same path that you think that it should. And there are other factors as well that come into play. It's not just battery voltage, there's other things too. And so what we're doing called open loop motor control, so that means so we're just telling the motors to run for a certain amount of time. And we just hope that it's going that far. Okay, now that actually isn't the best way to run a robot. A much better way to run the robot is to do what's called closed loop motor control, which is not something we're going to do today, but we will do later. But basically, the idea with closed loop motor control is that, excuse me, instead of telling the motor to just run for a certain amount of time, what you do is you tell the motor to turn on, and you let the motor run until the shaft that's on the wheel has turned a certain amount of times. Now, how do you know how many times it's turned? Well, you need to have a sensor on the shaft. And so the sensor is going to do what's called feedback loop. Okay. So the Arduino is going to be watching the sensor. And so the Arduino will know how many times the wheel has turned. And so rather than just telling the motor to run for a certain amount of time, you're going to tell the motor to turn on, and you're going to watch the shaft that's on the wheel, and you're going to wait until it has turned the number of times that you want it to turn, and then you're going to tell the motor to stop. So it's not time-based, it's based on the feedback that you get from the sensor. So that is called closed loop motor control, and that is a much, much better way to run a robot, but it's also much more complicated. And so I firmly believe that before you try to dance, you should first make sure that you know how to walk. And we are still at the point where we're still trying to learn how to walk. Okay, so don't worry, we will talk about closed loop control later. But for today, I want to keep things really simple. I want you guys just to experience the thrill of seeing a robot actually move around under your control, even if the movements of the robot aren't exactly what you want them to be. I want you to see that they're close. Okay, so what you're going to do is you're going to program the robot to move 3 feet, turn around, come back. Do not be surprised if it doesn't come back exactly where it should. And do not be surprised if you run this test 3 times and each time it comes back to a slightly different place. Okay, that's normal. Okay, now, in order to get credit for this assignment, what I want you to do is I want you to take a video of your robot as it moves through the pattern that I just described. And I want you to keep the video running as you make the measurement the measurement of what's the distance from where the robot stops to where the robot started. And I want you to announce to the camera what that final distance is. Okay. So when you upload that video, then I'll give you credit for this. And by the way, I think that it's important to point out this assignment is going to count as much as a midterm exam counts. Okay. So this is not just a 10-point assignment. This is a 50-point assignment. This is a midterm exam. Now, some of you are going to find out that your robot isn't going to work and you can't figure out why. So if that happens, don't freak out. Okay. There are a huge number of things that can go wrong, some of which are beyond your control. Like, for instance, maybe you got a bad H-bridge. Maybe you got a bad Arduino. More likely, you've got a bad motor. Hopefully, you guys remember that some of the motors are just bad. And they're bad for a lot of reasons. One is maybe they've got the more friction inside the gearbox than other motors do, and so they're going to run more slowly. Some of the motors have so much friction that we couldn't even run them with the H bridge. It didn't have enough power to run them. If you are one of those people who has trouble with the motors, I want you to go into the Ames office. I have purchased some new motors. I purchased these motors from a different supplier. Hang on, my throat is really bad. Okay, so I bought these new motors from a different company that I bought the other motors from. I paid a little bit more money for the motors this time than I did last time. These new motors are supposed to be better. The wires on the new motors are definitely better. The way that the wires were attached to the old motors, they sometimes broke off. These new motors, they did a much better job of attaching the wires. And also these new motors, supposedly they've screened out the gearboxes that have the high friction. So if you have trouble with the motors, go into the Ames office, talk to the people in there. There's one person in particular whose name is Nancy that most of you know, but maybe some of you don't. Nancy is the office administrator. She's the one that runs the school. She's got more power than the principal does. Okay, so you don't want to piss her off. You got to be nice to her. She's a wonderful person. You'll love her. Don't tell her I said that. I don't want her to get a big head, but it's true. She's a wonderful person. So if you talk to Nancy, and she has a bunch of these motors that I recently purchased, and she will give you some of these new motors. Okay, so anyway, back to what I was saying before, is that if your robot doesn't work and you can't figure it out, don't freak out. I promise I will not penalize you if you can't get the robot working by the deadline. Okay. If you need a little extra help, if it takes you a little longer than it takes the others, that is absolutely okay. I am not going to make you use a late pass if you can't get this done in time. And most importantly, I will not dock you for being late. Okay. So don't freak out if you can't get this working. But I would like, if possible, I'd like you guys to have this working before we meet next time, which will be this coming Thursday. Okay. I'd like you to aim for that as a goal, but that is not an absolute requirement. Okay. So with that being said, do you understand what it is that I want you to do? So type into the chat box yes if you understand. Type in the chat box. If you have a question, type your question into the chat box. Okay, I'm seeing a lot of yeses. I'm not seeing any nos. Okay. All right, well, that's your assignment then. And it is now 10 minutes before 3. So that means we have more than a half an hour left. My goodness, we've got like an hour and 20 minutes. We got a lot of time left for you to work on this. So I'm going to end the Zoom session right now. Please remember, that does not mean the class is over. That does not mean that you can get on your computer and play games. You need to use this time to work on your robot. So what I want you to do now is I want you to take your Arduino and your H bridge and 2 batteries. You need 1 battery to run the motor, and you need a 9-volt battery to run the Arduino. Put them inside of your robot and program the Arduino so that it follows the steps that I told it to, and you should be good. Okay. All right. Well, with that being said, you guys, you can go ahead and type bye in the chat box and head out. If you had a question that you wanted to ask me privately, here, I'll turn off the recording so we can talk in private.